that, we'll need to design transportation systems and habitats able to meet our needs. Engineers are designing, building, and testing these systems right now.
You may be wondering, how do they achieve this, and what steps do they take? The engineers use what's called the engineering design process. This process involves a series of steps to guide them in developing a solution. Each piece of technology on the space station and in your home or classroom involves engineering. But what exactly do engineers do? Well, they use science, math, and their own ingenuity to create solutions to technical problems. Examples of technical problems could be developing more efficient light bulbs or vehicles, lighter sneakers or aircraft, an orbiting space station, and transporting humans to Mars.
Yeah, Mars is great.
Here's one example of what the process looks like.
Step 1, identify the problem. Step 2, identify resources and constraints. Step 3, research. Step 4, develop solutions. Step 5, select the best solution. Step 6, build the solution. Step 7, test and evaluate the solution. Step 8, record and present the results. And step 9, improve the solution.
Take a look at the space that we are currently living and working in. This space is filled with things that have been engineered using the engineering design process. Some of these items are low-tech, like packaging, storage compartments, and fasteners. And some of these items are high-tech, like computers, cameras, and science experiments.
A great example of an engineering solution to something you might be surprised is a problem in microgravity. How do we drink fluids? How do we keep them contained? And how do we get them in our mouth without making a mess everywhere? Here's our standard drinking pouch. I've got some grape drink in here and a very nicely designed straw. It's just perfect for living in space. If we didn't have this straw, start to see some fluid coming out there. I don't want to make too big of a mess, so I'm only going to demonstrate what would happen for a second if we didn't have our straw here. And this would come right off. It's getting on me right now. So let me drink this up. But as you can see, we have a clasp here, very nicely designed. It pinches the straw at this point here, and that keeps more fluid from coming up the straw. And that way, if you want to drink something, you just open it up when you need to drink. You have to remember to close it again before you pull it out of your mouth. Otherwise, you're going to get more fluid coming out.
Hey, Tom, you're floating. I think that's not convenient for working, no?
That's true. Got a little bit of a problem in that if I do any work with my hands, I'm going to be pushed away from where I'm working. And if I have to find a place to put my feet, which I really want to do in order to get any work done, sometimes I can't find a place to put my feet. Still working on it. So I got a problem.
Based on astronauts' feedback and data, we developed these rounded hand and foot rails so that you can stay in one place comfortably for short periods of time. To maximize comfort, we also have these socks that are padded with rubber on top and bottom. For longer periods of time in one workspace, we engineered these foot restraints with cloth straps. You can slip right in and adjust them.
Thanks for exploring the engineering design process with us.
I'm going to send it back to Earth so you can solve your own engineering problems using this process.
See you again soon.